Good afternoon, friends. In my last lectures, I explained about nuclei, active nuclei and inactive nuclei, shielding and deshielding. Okay, active nuclei are further divided into two types of non-quadrupole nuclei and quadrupole nuclei. Okay, non-quadrupole nuclei is a spin equal to a half, and then quadrupole nuclei have a spin does not equal to half. Okay, and non-quadrupole nuclei have a spherical structure and quadrupole nuclei have a ellipsoid structure. Why is it important this type of study? Because non-quadrupole nuclei is important for a NMR spectra and give a sharp peak. Okay, and quadrupole nuclei give a broad peak. Okay, after a transitions and not very useful for a NMR spectra because quadrupole nuclei have a spherical structure, and due to spherical structures only two types rotation is possible for quadrupole nuclei. First is a clockwise and second is a anti-clockwise, because all sides same movements. And in a ellipsoid nuclei have a many types of rotation because all side not same. Okay, and because of many types of rotation, ellipsoid nuclei give a broad peak after a transition, and in my next slide I will explain. Okay, degenerate level. What is a degenerate level? Same energy level is called a degeneration. Okay, it's a same energy level when when not apply any magnetic field, it's a degeneracy level, same in degeneration. After applying magnetic field, nuclei absorb radiations and transitions possible, and the nuclei transit ground level to a higher energy level. Okay, and because of this type of transition, nuclei give a peak and the spectra, and that type of a degenerate level is for a spherical nuclei, so that after a transition give a sharp peak. Okay, but ellipsoid nuclei does not equal to half. Okay, spin does not equal to half, then spin is a 3 by 2, and according to this formula, four degenerate levels. Okay, for a ellipsoid nuclei. For example, a boron is a non quadrupole nuclei, and because of a quadrupole nuclei, boron have a 3 by 2, spin is a 3 by 2, and degenerate level equal to 4. And because of a 4 degenerate level, boron give a broad spectra, not give a sharp spectra, and broad spectra is not a very useful for a NMR spectroscopy because not give a exact information. Sharp spectra give a exact information, but broad spectra not give a exact information. So quadrupole nuclei not very useful for NMR spectroscopy, and non-quadrupole nuclei are useful for NMR spectroscopy. Okay, thank you, friend. In my next slide I will explain the other information related to spectroscopy. Okay, thank you.